Chatbots, an information retrieval survey by Samuel Adkins. Hello, this presentation will cover what chatbots are at a high level before taking a deeper dive into AI-driven chatbots and the natural language processing that goes into it. Starting from ground zero, we ask, what is a chatbot? In the most simple terms, a chatbot is a program that simulates human conversation to achieve some task. It could be as simple as a one-line dialogue with yes or no text options, or as sophisticated as your Amazon Alexa. This is what a chatbot is at a top service level, but as we discuss later, there will be many different ways that a chatbot can be made, and as technology has advanced over recent years, especially in the fields of AI and natural language processing, the types of chatbots we are able to produce are becoming more and more effective and complex. Applications of chatbots are everywhere. Chatbots offer a 24/7 availability, diverse language capabilities, reduced cost, and much more over traditional human agents in many industries. Some of these examples are virtual voice assistants on smartphones, customer support chatbots for e-commerce. The rideshare company Lyft has a chatbot that helps you request a ride via chat. You can use it on Facebook Messenger or Slack. Whole Foods, the grocery store, employs a chatbot app that can assist with recipe searches and can even understand searches using food emojis, which could be useful for someone that, say, doesn't know the name of a particular fruit or item, but knows what it looks like. There's also bank tellers, hotel desk clerks, and the list goes on. Now that we know what a chatbot is and when and where it's applied in some examples, let's look at the main mechanisms that make a chatbot. I've broken it down into three main mechanisms. We have rule-based, AI-driven decision-making, and hybrid/live agent intervention. Rule-based processing is pre-programmed cause and event scenarios, typically triggered with click and yes or no responses. This could be done through a dialogue tree with a comprehensive backlog that could understand certain keywords or specific phrases. And this type of chatbot requires that the user inputs queries that directly match the pre-programmed scenarios. So in some senses, this case can be very limiting, but it also can be very fast and inexpensive to create. AI-driven decision-making, or AI chatbots, utilize advances in artificial intelligence, specifically natural language processing, or NLP, to interpret semantic meaning in sentence structures, then extract meaning from user input. Rather than pre-programmed input-output events like the rule-based processes, NLP can try to figure out what the user wants and will come up with a response based on the available data. This is usually reserved for large organizations like e-commerce websites where large amounts of data is available. And then lastly, we have live agent intervention or hybrid chatbots. This chatbot mechanism allows the bot to directly connect a customer to a human available agent in the appropriate area or field. This is not a hybrid exactly in the truest sense, since the conversation is usually passed off to the human agent. While this is not every type of chatbot, I feel that these three main mechanisms can be seen as a parent class to their subclasses, such as support or hybrid bots being tied to live agent intervention, and skills chatbots being really just a comprehensive rule-based chatbot, and so forth. None of these mechanisms are necessarily better than the other, as the design of a chatbot is typically very domain-specific and created specifically for a narrow application within an industry. This being an informational retrieval survey in a course that focuses largely on NLP, we will take a deep dive specifically into how AI-driven chatbots work and see how NLP works in action. NLP, or natural language processing, is what makes AI-driven chatbots possible. NLP combines linguistics, computer science, and artificial intelligence, and uses elements of both machine learning and deep learning to achieve their task. The goal of NLP is for computer systems to achieve an accurate understanding of natural language input. If you look to the diagram, you can see how these fields and subfields overlap each other. There are simpler AI chatbots that may restrict the use of machine learning to simply calculate the classification probability for the semantic meaning of the user input based on the data used prior of deployment for training. For example, large corporations, which have huge inventories and volumes of data, may use machine learning chatbots to help find components in the company. On the other hand, we have the most complex types of AI chatbots, like Google Assistants, which are context-enabled chatbots. This advanced type of AI chatbot makes use of previous discussions to learn and evolve over time while spent with them through the machine learning and artificial intelligence. Popular examples of context-enabled chatbots are, as mentioned previously, Google Assistant, but also Siri and Alexa. Regardless of complexity, AI-driven chatbots uses NLP to some extent in the subfields within it to simulate conversation. So now that we know that AI-driven chatbots are really held up by natural language processing, we can look at the pillars of natural language processing that then make up the chatbot. There's the dialogue system, the natural language understanding, NLU, and the natural language generation, NLG. Whatever it may be, every NLP system needs a dialogue system. A dialogue system, sometimes called a conversational agent, is a computer system intended to communicate with a human. Dialogue systems may employ one or more of text, speech, graphics, haptics, gestures, and all other modes for communication on both the input and the output channel. But of course, most commonly we see text-based and voice-based communication. Natural language understanding is a subdomain of NLP seen previously in the Venn diagram. It's possibly the most important component of NLP chatbots, as it is responsible for accurately deriving the intent of the user's input. Natural language understanding is considered an AI hard problem, which means solving it fully is equivalent to solving the central AI problem. And then lastly, NLG, assuming that the input is parsed correctly during NLU, natural language generation is programmed to create a response and present it back to the user. Let's look into natural language understanding a little deeper. The scope of NLU is massive, but all systems that employ it share these essential components. 1. A lexicon of the language. A lexicon is more than just a dictionary. It puts words or word strings and phrases into a structure that natural language understanding and NLP systems can use for analysis. A computer does not read a word typically how we read a word. Second is the parser and grammar rules. A parser and grammar rules break the sentence into internal representation and smaller components. And lastly, a chosen semantic theory. A semantic theory is used to derive the meaning from context. Semantic parsers convert natural language text into formal meaning representations, and interpretation capabilities depend heavily on the semantic theory used, such as naive semantics or stochastic semantic analysis. Then, the third pillar of NLP and AI-based chatbots is the natural language generation. Typically, stages of this pipeline model include content determination, document structuring, aggregation, lexical choice, referring expression generation, and realization. Going a little deeper in each one of those, at the content determination stage, the AI chooses what information to respond with. This is done through content analysis, where information is filtered and the main topics are identified. This stage also includes data understanding, where covariance between source documents and final content is analyzed, typically with machine learning. Next, the document structuring is the stage which organizes the chosen key information from the previous step. A document plan is initialized and the narrative structure is decided based on the classification of the data. Third, we have the aggregation stage, which merges similar sentences to summarize the data and improve overall readability. Next, the lexical choice puts the words and sentences into concepts. Fifth, referring expression generation creates referring expressions, also known as noun phrases, that identify objects and regions. Lastly, realization creates the actual text in accordance with the rules of syntax, morphology, and orthography that is programmed beforehand. An alternative approach to the typical pipeline model is end-to-end machine learning and or deep learning that is applied to build the system without separate stages. This is sometimes called black box NLG or neural language generation, and although it's achieved various levels of success, it's overall been deemed not mature enough to be used for natural language generation and requires a very large amount of data to achieve good success. Now that we've gone over the main mechanisms that make up a NLP or AI chatbot, we should talk about some of the advancements in NLP and deep learning and how it's affected chatbots. Specifically, multilingual chatbots. A huge benefit of chatbots is the potential for a single chat agent to know several languages and thereby greatly increasing the scope of its application. Now, a fully functional multilingual chatbot needs to be able to decipher the language, understand exactly what the user wants, and respond naturally. However, chatbot localization is not as easy as taking an English language chatbot and translating all of its contents to a vernacular language. A fully functional multilingual chatbot needs to be able to decipher the language, understand exactly what the user wants, and respond naturally. This is difficult to say the least, but deep learning has been revolutionized in NLP with multilingual models such as Google's BERT, which utilizes a new transformer architecture. Popular models today include Laser, which is a zero-shot transfer-based model made by Facebook, which essentially creates a vector representation of sentences that are generic with respect to the input language and task. Essentially, Laser maps sentences in a highly dimensional space in hope that the same statement in different languages will be the neighbor in semantic vector space. Then we have MBERT, the multilingual adaptation of BERT that I mentioned previously, made by Google, which is trained on 104 languages and is one of the main reasons there will be so much progress with multilingual models. Another one is XLM, which is an enhanced BERT that uses supervised training to expand upon the transformer architecture. All of these models use mass language modeling, which is a newer deep learning technique to learn text representations, predict missing tokens, and more. A strong example of this newer NLP modeling being used for a chatbot is Ava, which is Asia Air's multilingual assistant that can handle 25,000 queries at a time in 15 languages. This chatbot has experienced great success over the last few years as it eased a lot of the issues caused by COVID-19 pandemic. Now let's discuss how chatbots are related to information retrieval. Information retrieval is concerned with extracting relevant information from a collection of resources. Chatbots search for the key information and meaning from the user's input and generate appropriate responses. The information retrieval process starts with users' queries, and in the case of AI chatbots, this could be seen as the first sentence or any sentence to the chatbot, such as, "How is the weather today?" Then the informational retrieval process searches to find a collection of related objects with various degrees of relevance. In the case of chatbots, the related objects is typically the calculated text response. Information retrieval systems, especially AI chatbots, compute a ranking for how well each object matches the query, and with the appropriate processing and merging, the response is realized and shown to the user. It is always important to discuss the ethical challenges around emerging technologies to help prevent disparities between users and unsafe or unintended consequences. The same, of course, goes with chatbots. The developers of chatbots must be careful to supply training data that is appropriate, otherwise they run the risk of the chatbot displaying racism, sexism, or the use of abusive language. A famous case of this has already happened with Tay, a chatbot that had access to Twitter and learned from Twitter itself. Within hours of going live, Tay began posting hate speech and had to be removed from the platform. There's also the consideration of the responsibility in responses. For example, when a female chatbot encounters sexualized abuse, is not reciprocating the negative language enough? In society, we assign morality to specific behaviors and actions. And so, is a chatbot that is complacent to abusive speech unethical due to the possibility of perpetuating that behavior? Perhaps a witty response or outright disapproval from the chatbot is a more ethical design.